In this video, I'm going to share with you a way to verify payload signature of webhooks. We already have this sample, and this one is taking advantage of Node.js, and you have to build your own server. In this case, what I'm going to share today is a snippet in Python to do that on a serverless environment. So this is for the ones using or interested in Webhooks API. First thing you need to do is post your secret token. I already posted mine, so the value for mine is this one. This is my APS webhook token for testing. So this is the first thing we need to do. After that, of course, we need to create, post the webhook subscribing to one specific event. I'm going to create a webhook for my ACC account or my ACC hub under this folder right here. So I need to grab this folder URL. For simplicity, in this case, I'm going to grab the folder URL from the address bar, paste the value here in this URL decoder, and now I can create my webhook. To create that, I'm going to use VS Code extension. So let me create it here. I'm going to listen for version added event. Inside scopes, I add the folder ID, and I also need to pass a callback URL. For testing, once more for simplicity, I'm taking advantage of webhooks.site. So let me grab my unique URL. Here I can paste it, and now I can create this new webhook. Right here, you're going to see that we have this new GUID for my newly created webhook with all details. And now I can start receiving notification for this event. So to trigger one notification, I can simply upload a file here. I have this very small file just for testing. Let me upload this one. And once this is complete, I should receive a notification right here. I'm going to pause the recording. And okay, I got the notification. Here you can see it. And the way it works is that APS backend sends the payload containing all the information you want, and also sends in the header this AXADSK signature. So we basically need to calculate a hash based on this payload to match, and this hash should match this hash provided by Autodesk backend. To do that, we found after a lot of investigation, we found this method right here. We used this method right here. Thanks Michael and Peter for helping with that. This is in Python, but you can do the same in a serverless environment using any language. After validating this method on my local machine, I'm going to validate that also in a Lambda server, in a Lambda function. So, okay, let's validate it. To validate this here, I simply need to pass the body, the hash string provided by APS backend, and also my key, my secret key to match, to calculate the hash from the body and match with this hash string. So first, let's add our hash string that we obtained from Autodesk backend. So I can copy this one here, paste it here. Sorry. Paste it here. And now I do the same for my body. So once you do that, if you want to validate on your local machine with the body that you got from webhook.site, always make sure you are unchecking these two checkbox here. If you do any formatting with the JSON, it is going to generate a wrong hash, and it will be a lot of headache. I spend a lot of time going through this. All right. So to summarize, make sure you uncheck these boxes, and then you can copy the payload. Now let's validate it in the body. And now I can run this code. And if you see here, there is a true, meaning the true is the return from the method that compares both hashes. The hash, the hash that was provided by APS backend, and the hash that we calculated using the body and the secret token. Okay. Now let's do the same for our Lambda function. For our Lambda function, we first you need your AWS account. Then you need to create a Lambda function. Let me call it Webhooks testing Lambda. Runtime is going to be Python. Just use the latest version, 3.12 available here. You don't need to change anything else. Okay, enable function URL. This is required. And also authentication type, none. Just for testing, once more for simplicity, I'm going to allow requests for any IP or non-authenticated users. So just type your name, runtime, and then enable function URL without any kind of authentication. This is just for us to test, for me to prove the concept, all right? For implementation, it's better, always good to keep it in a secure way. So let's create our function. I'm going to pause once more. Okay, and once done, we need to configure our URL. So go over configuration, function URL. You already have a URL available. This URL is the one we are going to use to send requests to connect, that connects with our Lambda function. The other thing we need to do, of course, is updating the code. I'm going to use this snippet. This snippet is going to also be available in a blog. So let me replace this with my snippet. As you can see, this is basically obtaining the hash from our header. This header right here, it contains the hash. This is also obtaining the secret key used to verify the hash from environment. You can hard code this for simplicity, but since this is a secret, it's always good to have that as an environment variable. And the body, since we are using a Lambda, the raw body is available through this event body field. I need to ensure, please make sure you don't format the body. If you try to format or make it available as a JSON file as in a JSON structure, this might break the usage of the function, all right? This is the same function we were using before, works in both cases. If we have a dictionary or if we have a string, is going to print the calculated hash, and it's also going to return to us the body just for us to check. Feel free to do any change. And in our logs, we are going to see that if this is a match, right? So let me deploy this function. Okay, deployed. I also need to specify the environment key in our environment variable. To do that, we can go over configuration, environment variable, edit, add environment variable. The key is going to be key, and the value is going to be our token, our secret token. Now add environment variable, and sorry, just remove this one. Now hit save. And now we have our environment variable and our code. Now we just need to test this with our predefined event, and then we can directly test, create a webhook for that, right? First of all, let's test with this event right here. To test with this event, I can copy this content, create a new request in Insomnia. In this new request, I'm going to specify this as a payload body. I also need to specify the header, and the header required is the one with the hash. This is the hash passed by Autodesk backend. And also we need to specify the Lambda function URL. Let me copy it here and paste it here. And now if we hit send, we can see that response is 200. We have the body here that we passed. And if we go over monitor, CloudWatch logs, in our most recent log, we see that the match was true. Okay, the hatch is the same, so it is working properly. Now let's create one webhook, but instead of pointing to webhook.site, let's point to our Lambda. And just so we don't make any confusions, let me delete this log. I don't need to delete this. Let's just create a new one. And this is going to be our URL. Let me go back to our webhook. Let me delete the previous one. Create a new webhook. Our callback is our Lambda callback. And our URN is this one right here. So let me pass this as a scope. Create this webhook. Okay, created. Now I just need to upload a new file. Let me upload the same file. Okay, this is a small one. And I just need to wait for a new log here. It should happen soon. I'm going to pause as soon as I pause the recording and resume as soon as I receive a new one. Okay, I got it. It is in the same file, but as you can see, this is the most recent one, 1958. We had this before, and this is the most recent one. Okay, with this new hash right here. This was the previous one. If you go over webhook.site, 85, 85, and this is the new one. So our Lambda function is working. Let us know if you have any questions on that. And yeah, I hope you will find this helpful. Thank you.